Observability 1.0 gave us more data than ever and more alert fatigue than ever. The average SRE dashboard has 847 panels. When something breaks, 34 alerts fire in 90 seconds. The engineer spends 20 minutes figuring out which alert matters, another 15 correlating data across tools, and 10 more identifying root cause. Total time to action, 45 minutes if the on-call engineer is awake, alert, and familiar with the system. Observability 2.0 inverts this entirely. AI agents don't just observe, they understand, predict, and fix. Problems are resolved before you know they existed. The three pillars of observability evolve with AI. Metrics become predictive analytics, not CPU is at 90%, but CPU will reach critical threshold in 47 minutes based on current trend, and here is the auto-scaling action I've already triggered. Logs become intelligent correlation, not thousands of log lines to search, but these 14 log entries across 4 services form a causal chain leading to the payment failure. Traces become causal analysis, not request flow visualization, but this latency spike originates from a database connection pool exhaustion caused by a deployment 12 minutes ago, and I've initiated a rollback. AI connects all three pillars into a unified understanding of system behavior. Predictive failure detection is the defining capability of Observability 2.0. The AI agent learns normal behavior patterns for every metric, log pattern, and trace signature across your entire system. When subtle deviations appear, a gradually increasing error rate, a slowly growing memory footprint, a drift in response time distribution, the agent recognizes these as early failure indicators based on historical patterns. In our benchmark, the agent detected impending failures an average of 47 minutes before they would have triggered traditional alerts. For 61% of predicted failures, automated preventive action, scaling, restart, cache warming, connection pool adjustment prevented the failure entirely. You never got paged because the problem never materialized. Alert correlation eliminates noise. Traditional monitoring generates 34 alerts for a single incident because each metric threshold fires independently. Observability 2.0 AI correlates these into one incident with root cause, impact scope, and recommended action. The agent understands that increased error rate in the API gateway, elevated latency in the auth service, and connection timeouts in the user database are one incident, database connection pool exhaustion, not three separate problems. Alert volume drops 97%. Mean time to understand drops from 20 minutes to 45 seconds. Engineers receive one actionable notification instead of 34 confusing ones. Auto-Remediation Playbooks execute fixes before humans are involved. The agent maintains a library of proven remediation actions, each with preconditions, execution steps, and verification checks. Connection pool exhaustion detected, agent increases pool size and restarts affected services, 94% success rate. Memory leak pattern detected, agent triggers rolling restart of affected pods, 91% success. Cache stampede detected, agent clears cache and enables request coalescing, 96% success. Deployment regression detected, agent initiates automatic rollback, 94% success. Database primary failure detected, agent promotes replica and updates service discovery, 96% success. Each playbook executes in under 2 minutes with automatic verification. Causal analysis across microservices is something no human can do fast enough during an incident. Your system has 200 microservices with complex dependency chains. When payment failures spike, the root cause might be 5 hops away, a configuration change in a service 3 deployments ago that reduced a connection pool size. The AI agent maintains a live dependency graph and performs causal inference across it. It identifies that deployment version 2.3.1 of the user service changed a connection pool setting, which caused pool exhaustion under peak load, which caused timeouts in the auth service, which caused payment failures in the payment service. This causal chain, invisible in any single dashboard, is reconstructed in seconds. Observability as code brings GitOps discipline to monitoring. SLO definitions, alert policies, dashboard templates, and runbook automation all live in Git versioned, reviewed, and automatically deployed. When a new service launches through your IDP, observability configuration is generated automatically, golden signals dashboards, SLO targets based on service type, alert policies calibrated to expected behavior, and runbook automation for common failure modes. When an SLO changes, the update goes through pull request review like any other code change. No more dashboards that nobody maintains, alert thresholds that haven't been updated since launch, or runbooks that reference services that were decommissioned 2 years ago. Real-world impact from teams running Observability 2.0. Total incidents reduced 80%, mostly through predictive prevention, not faster response. Mean time to resolution for incidents that do occur, from 47 minutes to 2.8 minutes. Alert volume reduced 97% through intelligent correlation. On-call pages per engineer per week, from 14 to 3.1, a 78% reduction in interrupted sleep. SLO compliance improved from 94.2 to 99.6%. Engineer satisfaction with on-call rotation improved dramatically. On-call weeks became manageable instead of dreaded. One SRE team reported 0 pages during a 30-day on-call rotation for the first time ever. Build Observability 2.0 in 4 layers. Layer 1, unified telemetry pipeline, metrics, logs, and traces flowing to a single analysis platform. If your data is siloed across 3 tools, the AI can't correlate. Layer 2, AI analysis layer, deploy agents that learn your system's normal behavior and detect anomalies. Start in observe-only mode. Layer 3, auto-remediation engine, encode your top 5 runbook procedures as automated playbooks. Test extensively in staging. Layer 4, observability as code, move all monitoring configuration to Git with automated deployment. Most teams have layers 1 and partially 2 already. Adding AI analysis and auto-remediation is the leap to Observability 2.0. Observability 2.0 isn't about more dashboards, it's about fewer incidents, faster resolution, and engineers who aren't afraid of on-call. AI agents that predict, correlate, and fix transform observability from a postmortem tool into a prevention system. Start by connecting your telemetry into a unified pipeline and deploying AI analysis in observe-only mode. The predictions will justify everything that follows. I'm AI DevOps Daily. Next episode: how AI is replacing the traditional site reliability engineer role.